Welcome, welcome. Let's get it started. Thanks everyone for coming back. I hope you had a great week since our last session. We have a really actually fun session today. This is a little bit different than last week's, but I think it'll be pertinent to a lot of people trying to do machine learning and trying to deploy models. We have Adrian on with us today. Adrian is an AI software evangelist at Intel, currently focusing on the OpenVINO Toolkit, teaching people about it and showing people how they can take their models from their local systems into production without having to build API servers or learn how to host models. Before that, Adrian was a co-author of the LandCover.ai dataset, which was kind of teaching people how to do machine learning and focusing on computer vision. And he was a computer vision researcher in his previous life, but he's now an evangelist teaching us all how to do machine learning better. So we're really excited to have him on. Thanks for coming.
Thank you, Ben. I hope this session would be really interesting for you.
Yeah, I think it will be. I'm stoked to learn.
So let's start. Okay, hi, my name is Adrian. I am AI software evangelist at Intel, and today I would like to introduce you OpenVINO, which is open source toolkit for optimizing and deploying AI inference. And what's important, you don't have to buy any additional hardware to use OpenVINO. You can utilize the hardware you have here in your laptop. And the second, even if you just use your CPU, your performance should be better than TensorFlow or PyTorch. So let's talk about the 7 lines of code you need to run faster real-time inference. As I mentioned, I am Adrian. I am AI software evangelist, and I am part of a bigger team. And together with Raymond, Paula, Anisha, and Juwo, we teach people what OpenVINO is and how to use it. But before we go to the presentation, let's go to the code, and I would like to show you something to grab your attention. And I'm going to run that notebook now. No worries, I will explain everything later, but now let's look at the performance. Look here, I have exactly here 130 frames per second, and I am running OpenVINO model here on my laptop. This is just CPU laptop. There is no any discrete GPU card. This is just CPU. So I will explain how to do it later, but now let's dive into OpenVINO Toolkit. So for now, no code, no worries. I think I presented only webcam. So yeah, I will present and explain code later. So let's go back to our presentation. I hope I have your attention now. And let's talk about the challenge. Why would you need OpenVINO? And let's assume this is you. Or your team, you already trained great neural network and it reaches almost 100% of accuracy. So you're sure that it can save the world. But to do it, you need to deploy it. And let me guess, what is your first choice? GPU, of course, right? But wait, do you want to spend $1,000 for GPU with as many frames per second as possible? Probably you need only 30 frames per second or maybe 50. So in that case, I think GPU is rather overkiller. So the second guess, cloud, right? But wait, you don't want to build an API, right? Even if you just use cloud, you still need to rely on internet connection and after that, still wait some time for the results. And what if you cannot send data anywhere? What if you must process the data locally? Is there something cheaper and available on the edge? And maybe just CPU you have already. Yeah, but running on CPU is rather slow, right? Almost every deep learning engineer, but it was. Is this still true? Let's check. So if your case is that you don't want to spend much money for GPU, you don't want to build an API, or you are forced to process data locally, I have the solution for you for fast inference, OpenVINO. And OpenVINO, as I said, is an open source toolkit for optimizing and deploying AI inference. And OpenVINO means Open Visual Inference and Neural Network Optimization. But it's not only for computer vision, it's also for NLP, audio processing, time forecasting, and many other applications. So let's start our OpenVINO journey. So let's assume you trained your network in one of these frameworks: TensorFlow, Keras, PyTorch, ONNX, Caffe, MXNet, or PaddlePaddle. Then you can convert it and optimize in OpenVINO and run on many Intel's hardware like CPUs. And when I say CPU, I mean Core you have in your laptop, I mean Xeon you have in your server. Also, I mean Atom, which is a low power device. You can run also on GPU. And when I say GPU, I mean this GPU already integrated into your CPU, like Intel HD graphics or Intel UHD graphics. And also Intel discrete GPUs card we launched last year, like Flex Series or Arc Series. Maybe you heard about it. You can also run on VPU, and VPU means Visual Processing Unit, and it's, for example, that device. This is Neural Compute Stick 2. This is USB accelerator. So if you plug it into your USB port, you have external acceleration. You are running on this device only. You are not using your resources like CPU or GPU. And of course, you can run on FPGA with FPGA AI Suite. And it runs on any operating system, Linux, Windows, or Mac. So what are the steps to run OpenVINO? Now, the first step is, of course, installation, right? You need to install OpenVINO. And there are many ways to install OpenVINO. You can use package managers like apt from Ubuntu or yum from Red Hat or Fedora. You can also use Conda or Docker. But I assume probably most of you are Python developers. So in that case, the easiest way is to use pip, right? Pip install OpenVINO or pip install OpenVINO dev for development package. So this was the first step, installation. And the next step is optimization. And Model Optimizer converts your model from original framework like PyTorch, TensorFlow, Keras, ONNX into intermediate representation, which consists of two files: XML with weights and biases, and binary file XML with architecture and binary file with weights and biases. But Model Optimizer not only converts your model, it also performs some number of optimizations like graph pruning or fusing some operations together. So after that, you have faster inference. How to use Model Optimizer? There are two ways now. The first way is using MO command line tool and provide some parameters, especially one parameter path to your model. If you additionally would like to compress weights to floating point 16, you just need to add compress to FP16 flag. So this was the first way to convert your model, and last month we released the new version of OpenVINO, and there is one more way to convert your model to IR. You can use Python API. And in that case, you don't have to use any command line tools, just, pure Python, and use function convert model, provide some parameters like path to your model and maybe input shape. Also, if you would like to compress to FP16, you can assign true there, and you will end up with Python object. So in that case, there is no files on disk, there is only Python object in your code. and in your memory. And as I mentioned, the product of Model Optimizer is intermediate representation. So from this to this, much simpler, much faster to run the inference. And there is one more optional step. If you really need very good performance or better than just conversion optimization, probably you heard about quantization, right? And it's also available in OpenVINO. You can quantize your network from floating point 32 to int 8 by using post-training optimization tool and providing some representative dataset. So far we installed OpenVINO, we converted and optimized our models, and optionally we quantized that model to int 8, and now it's time for the last step. It's time to run the inference, and in that case you just need 7 lines of code. The first one, import OpenVINO. Next, load your image or text or audio or any data you would like to infer on. Then initialize OpenVINO by creating core object. Read model, in this case from disk, it was converted by ML command line tool. And compile for some specific device, like CPU for example. Get the handle to the output layer and run the inference, giving the input and getting the output from the output layer. So in case of image classification, from this to this in just 7 lines of code. Okay, but maybe now you are wondering, what device can I put in compile model function? Well, we support many different Intel's hardware like CPU, once again, Core, Atom, Xeon, whatever you want to run on. GPU, and once again, this means GPU already integrated into your CPU, like Intel HD graphics, Intel UHD graphics, you have already there. But also it means some discrete GPU cards like Flex series, Arc series, and so on. And if you put here Myriad means it will run on this device, Neural Compute Stick. So you will use this USB accelerator. But there is also one more very important device, Auto. And Auto is a virtual device, so Auto is a special kind of the device that will select the best physical device for you, and it will configure the device based on your hints and handle exec logic for multiple devices. So this is the recommended way. If you don't know what device is the best for you, or you would like to have portable application that, for example, you would like to deploy on CPU, sometimes on GPU, whatever is available, right? If you use Auto, Auto will select device automatically. So of course, if you know that you would like to use only resources like CPUs or GPUs, put CPU or GPU, no problem. But in most cases, Auto is the recommended way to use it. And what about these performance hints I mentioned? Well, let's assume that you care about latency. In this case, Auto will select one device from candidate hardware device list, for example, CPU or GPU, and Auto will create single stream to infer one by one, so you know that you have as low latency as possible. How to use it? Well, during compilation in compile model function, you just need to provide additional config performance hint equals latency. If you care about throughput, Auto will select once again one device, the best for throughput, and will create multiple streams, in that case, to infer concurrently with auto-batching. How to use it throughput? The same, provide additional config, performance hint equals throughput. And there is one more mode for performance hints, and it's called cumulative throughput. And what's the difference between throughput and cumulative throughput? In this case, auto will select many devices, not one, but many devices from candidate hardware list, and it will create, of course, multiple streams to infer concurrently with auto-batching and preserving device priority. So, for example, if you know that you would like to run on DGPU in most of the time, you can specify that discrete GPU is the most important device for you, and auto will care about it. And once again, to use cumulative throughput, please provide additional config performance hint equals cumulative throughput. But I mentioned auto-batching a few times, and probably you are wondering what auto-batching is. So I would like to explain it now. So auto-batching, it's a feature in OpenVINO that would create batches from your inputs automatically. So, for example, let's assume that the best batch size is 4. So auto-batching will wait for the 4 inputs, and where 4 inputs are ready in the batch, it will proceed to the inference. And the same for the second batch, right? So we are waiting to fill the batch and then to the inference. And once again, the same for the third batch, and so on, so on. So to use auto-batching, you don't need to do anything. It's enabled by default. If you use auto device or GPU and you specify your performance hint equals throughput or cumulative throughput, auto-batching will be enabled by default. So I think that's really nice. Okay, but we are talking about mostly about computer vision, right? Because I was talking about loading images and so on. But what if your application is NLP model, for example, or audio processing? What if your application have inputs data with different shapes, right? Now, the usual approach in that case is that you need to add some padding at the end, like zeros, for example, or if the input is very long, you need to split into parts and then infer one by one. But if you use dynamic shape from OpenVINO, your network will be resized automatically, and you don't have to worry about it. It will be resized based on your input. And how to use it, dynamic shapes? You need to do the same till this step. So now we already read the model from the disk, and now we need to get the handle to the input layer, then read the shape of the input layer, and assign -1 to one of the dimensions. If you assign -1, it means it's unknown. It will be dynamic. Of course, you can also assign dimensions with dimension object with lower and upper bounds, for example, 1 and 384. In that case, it's recommended way, of course, if you know the upper bound, because the memory usage will be less than in the case that you assign just -1. So, okay, we assign -1 or dimension object with some bounds, and now we need to reshape the model. Now model knows that it's dynamic model. And we compile once again for some specific device. And probably you think that you can put CPU, GPU, myriad auto, everything here. Not really. For now, it's CPU only what is supported, but no worries, we are working on this right now, and I think in the next version of OpenVINO, it will be available to run dynamic shapes on GPU as well. Okay, but let's talk about some applications. We have and share more than 270 pre-trained and optimized models like object detection, pose estimation, action recognition, depth estimation, OCR. It works with English, it works with Chinese, and many, many more. So if you have just idea and you would like to prototype something, just create proof of concept in OpenVINO. You don't have to convert, you don't have to train any model, you don't have to convert your model. You can use one of our models from Open Model Zoo. And to get access to all these models, please scan QR code in the corner and you will land on our GitHub when you can find all of these models. And you remember I asked a very important question at the beginning. Is running on CPU still slow? And to answer that question, we performed some benchmarks. And we selected 3 different networks. ResNet50 for image classification, SSD MobileNet V2 for object detection, and BERT base case for NLP tasks. And we measured throughput in frames per second for floating point 32 model. And of course, the best results are for Intel Xeon. Yeah, because this is server CPU. So we are not surprised. But what's important, if we use core, which is like CPU from your laptop, right? 12th generation, 10th generation, even 8th generation, the results are also pretty good. In case of Intel Core i3, 8th generation, and 8th generation is from 2017, so it's 6 years old CPU, and in case of image classification or object detection, you still have more than 50 frames per second. I think this is great, right? And if we talk about BERT, which is the most, the really heavy network here, you still have 15 sentences or inferences per second, what I think is enough in most cases, right? If you would like to learn more about different hardware, about different models, please scan QR code. There are many charts you can look at and see what performance we have for against different Intel's hardware. If you would like to benchmark your app, your model, you can use benchmark app command line tool, which comes from OpenVINO development package and provides some parameters like path to your model and device you would like to benchmark. And that's all from the theoretical part. Let's go back to our code to explain you everything now, what I started to show you at the beginning. This was, and this is, live object detection with OpenVINO, so I'm going to explain everything and run code once again to discuss with you a little bit. So first, of course, we need to import some Python packages, and of course the most important in that case is OpenVINO, right? Then we are going to download model, and we are going to use SSD Lite MobileNet v2, and it comes from Open Model Zoo, so we are going to use OMZ downloader. It's a command line tool from OpenVINO development package, and OMZ downloader is able to download any model from Open Model Zoo. So yeah, we are using it to download the model, and this model is in TensorFlow format. And I hope you remember that I mentioned that we need to convert the model from TensorFlow, PyTorch, whatever, to intermediate representation to be able to run in OpenVINO, right? So to do so, we are going to use OMZ Converter, which is another command line tool from OpenVINO development package, and it's able to convert any model from Open Model Zoo. And once again, if you would like to convert your model, you still need to use Model Optimizer directly. In this case, when we use model from Open Model Zoo, we can use OMZ Converter. And then, of course, we need to initialize OpenVINO, read model from the disk, compile model for CPU. We are going to use CPU, get input and output nodes, get input size, specify classes we would like to detect, then colors for these classes, function to post-processing results, like creating boxes around objects, doing non-maximum suppression to get rid of many overlapping entities, and return, of course, labels, scores, and boxes. Then function to draw boxes on the image, very simple function, right, using OpenCV. And main processing function, we are creating video player here to stream our webcam, to stream also video file, whatever you prefer. Then we are getting frame by frame, resizing to fit in a neural network input, creating batch of just with one image, because this is, latency application, I could say. We are doing inference here and time measurement to calculate mean processing time. Post-processing results, creating these boxes and so on. Draw boxes on the image. As I said, calculating mean processing time from the last 200 frames. Putting all this information on the image and showing everything directly in the notebook. So let's run it once again. Okay, so this is me. This is my cell phone and my cup. Everything works smoothly. As you could see, I hope that I am person, so I think it's correct. And what's important? And of course, important is inference time. 7.7 milliseconds, what gives us 130 frames per second. It's nice, right? Because I am using SSD Lite MobileNet on this CPU here. I am not using any GPU. I am not using any server, cloud API, nothing, just using CPU. This is Edge AI, right? But there is also something interesting I would like to show you. Let's go back to the compile function and let's change CPU to GPU. The startup time is a little bit longer. You can see asterisk here, right? Oh, it's done. Good. Go back to our function. We had 130 frames per second before on CPU, and now I changed device for GPU, and once again, this is GPU already integrated into my CPU. It's Intel HD graphics. And I have 170 frames per second, 40 frames per second more. And look, I didn't buy any new hardware in the last 2 minutes, right? I just changed one line of code and I am utilizing what I have here in this laptop. Okay, 170, almost 180. Let's stop and let's try Auto device. You remember, I recommended you to use Auto, because Auto is our recommendation. Let's provide additional config saying that our performance int is latency, right? Because this is latency application. We would like to have results as soon as possible. Oh, it's already done. It was loaded. And 130 for CPU, 170 for GPU, and for auto, it's more than 180, right? There are additional, of course, it varies because, you know, my computer is streaming now to you, my screen and my webcam and so on. But as I said, Auto is our recommendation and should be the best device because it will select the best device, the best physical device for you. So 176, 180 sometimes. Yeah, that's good, I think. And of course, if you don't have webcam, you can run it on video file and have the same performance. Why I am saying that you can run on webcam or URL or video? Because this is open source, right? It's already on our GitHub. You can clone this repository and try at home. Let me show you. It's here, right? So I'm going to, yeah. Let's zoom in. And so this is OpenVINO Notebooks repository. You can find many useful notebooks there, as well as these notebooks I presented to you, as these notebooks I'm going to present you in a minute. So if you would like to try them at home, no worries, clone this repository, run on your computer and see what performance you have. Okay, so this was the first notebook I wanted to show you. Now it's time to jump to the second notebook, and let's scroll up. This notebook is for quantization of NLP model. So I'm gonna show you quantization. I'm gonna show you difference in performance between PyTorch model, OpenVINO model, and OpenVINO quantized model. And I would like to prove you that OpenVINO is not only for computer vision. That's why here we have NLP model. I'm not going to run this notebook now. And why? Because it would require us to wait at least 5 minutes. It's a quite long notebook, but I promise you that I pre-ran this notebook just before the event, just 1 hour ago. So if you would like to run it yourself, no problem. It's there in OpenVINO Notebooks. Now I'm going to scroll and show you the results I have when I pre-run this notebook an hour ago. Good. So first we need to import, as usual, some Python packages, especially OpenVINO here, and additional functions and classes for POT, post-training optimization tool. Then we are specify URL to model we are going to use. This model is from internet, and we are unzipping that model, of course. And then very important thing, because I need to admit we don't support PyTorch models directly for now. We are working on this, so the same as with dynamic shape for GPU, it should be supported in the next version of OpenVINO. But for now, you need to export your PyTorch model to ONNX first, and then ONNX model to OpenVINO. So we are going to export that model, then using this model optimizer. So here, it's not the model from Open Model Zoo, so we cannot use OMZ converter. We have to use MO command line tool directly, and we are doing it. Then provide some data set, because as I mentioned, to quantize anything, you need to provide some data set, right? To do the full integer quantization. And then we need to define some classes, implement some classes like data loader or accuracy metric, and this is optional, right? Accuracy metric is optional, but we would like to know what performance, what accuracy we have before the quantization and what performance we have after the quantization. And then we specify quantization pipeline. There are many steps here, right? More than 9, even 9. So yeah, I know this is long, right? But the same story. We are working on this, and I saw that in the next version of OpenVINO, there will be just one function, quantize, nothing more. But for now, we need to specify these steps like loader, accuracy metric, pipeline, and so on. And the accuracy before the quantization is 0.86, quite nice, right? And then quantization took 67 seconds, and after that we have accuracy 0.85. It's nothing surprising, right? Because doing quantization, we should expect a little accuracy drop. And let's go further. Then we are initializing OpenVINO, we are reading model, and here we are going to use dynamic shapes, right? We are assigning -1 to one of the dimensions. And of course, compile model for CPU. We cannot use anything else because this is dynamic shape. Then we are going to skip this part. This is just checking if the model is working correctly. It's working, I promise you. And then the most important part, we would like to measure PyTorch model, measure time for PyTorch model for converted model to OpenVINO. PyTorch model exported to ONNX and converted to OpenVINO, and this is in floating point 32. And then we are going to measure time for int8, so after quantization. And the results are here. In case of PyTorch model, I hope you can see that. Maybe I will zoom in once again, because font is rather low. PyTorch model gives us 3.0 sentences or inferences per second. Okay, that's good. Three inferences per second are okay. But if we convert that model to OpenVINO and we don't change anything, right? Because we are just pruning some operations, fusing layers together, and just providing a new format, nothing more. We are not changing the processing graph inside. The performance is 21.4 sentences per second. It's 7 times faster just converting the model, right? And if we additionally quantize that model to int8 with a little accuracy drop, as you could see, the performance is 51.8 sentences per second, what is 2.5 times faster than floating point 32 model, and it's 17 times faster than PyTorch itself. I think this is great, right? Because it's like, I could say it's a free lunch. You already have that hardware, and you are just using some optimizations for that. That's nice. Okay, let's go back to our presentation again. And the demos I presented to you, as I said, come from OpenVINO Notebooks repository. And if you follow these 4 steps, create the environment, on the repository, install requirements, and launch the notebooks, you will have the same results. So I recommend you to scan QR code in the corner and clone the repository, run it at home, and see what performance you have. And this repository is still growing, so we now have more than 50 different notebooks teaching you different aspects of OpenVINO. Like I didn't mention about that because we don't have much time, but there is also synchronous mode, asynchronous mode, many different additional features like pre-post processing, pre-post processor, or async infer queue, and many more. So you can find all of them in our repository. And remember just that the new notebooks appear all the time. So yeah, as I said, it's growing. But what if you don't want to install anything, or you cannot install anything, or even better, you would like to try OpenVINO, but you don't want to buy Intel's hardware like many CPUs, GPUs, and so on? In that case, you can use Intel Developer Cloud for the edge. And this is a free cloud service to perform OpenVINO experiments in Jupyter Lab environment. And to get the free access, just scan QR code and do it. And maybe you are wondering now if OpenVINO is just proof of concept. Maybe I'm trying to find some testers. Nope, it's not true. OpenVINO was already adopted by many IT industry companies. Maybe you recognize some of them. I recognize, for example, Accenture, HP, or Dell. So if you worry that OpenVINO is proof of concept, it's not true. It's production-ready solution, and it was already adopted by many companies. But at Intel, we have OpenVINO, of course, but we have also many different frameworks, and like one API, for example, is low-level library. It's used by TensorFlow, the newest version of the latest version of TensorFlow, for example. And we also contribute to some frameworks like PyTorch, like XGBoost, Scikit-learn, SciPy, NumPy. I know probably most of you are MLOps, right? But you are working with, you work with developers, with deep learning engineers, and so on. So maybe you can recommend them to try some our extensions for these frameworks to have better performance on Intel's hardware, right? And my main takeaways from today are that you don't have to buy any additional hardware to use OpenVINO. You can utilize the hardware you have in your laptop. The second, even if you just use your CPU, as I showed, and the performance should be better than TensorFlow or PyTorch. And third, the best way to learn OpenVINO is OpenVINO Notebooks repository. But don't just believe me. Try it yourself, see what performance you have. And before we go to the questions, I have 2 extra for you. The first one is you can win $50 in swag if you scan this QR code and fill the survey. This is very important for us because we are looking, for your feedback, we are looking for your review, and so on. So we would like to create better materials in the future. We would like to know if OpenVINO is easy to use, if OpenVINO is nice or not, right? So please scan this QR code and fill the survey. It doesn't have to be done now. You can do it in 2 days or something like that. And 2 lucky people will win $50 in swag. So this was the first, my first extra for you. And my second extra, this is QR code to connect to me on LinkedIn. And if you do so, you will get that nice t-shirt, right? 10, of course, I have a limited number of t-shirts. So let's say that first 10 people who connect to me on LinkedIn will get this nice t-shirt. Once again, t-shirts for AI developers with OpenVINO, Intel, and some Python code. First 10 people, so don't wait, connect to me. And that's all from my side. I am waiting for your questions.
Thanks so much. That was a fantastic showcase. That was really, really incredible. So how long have you been on the OpenVINO kind of evangelist team?
Well, I joined Intel in September 2021, so it's more than 1 year, almost 1.5 years.
Oh, that's awesome. That's really, really cool. And have you used OpenVINO to deploy outside of your local system? Have you actually deployed it into production on some open server?
Not really. I never tried it before. When I was working for previous companies, I never heard about OpenVINO before, so didn't try.
That's fair. I don't think that we have any questions from the audience at the moment. Do you have any other useful tricks or anything that you've run into, any development tricks that you've had with OpenVINO?
Well, I can tell you more about Notebooks repository, because I think this is the most important one. If you can turn on my screen once again. As I said, we have many different notebooks right here. So for example, Hello World is a very simple notebook to just start with OpenVINO. Then OpenVINO API, many frontends. I didn't mention about that because we don't have so much time. So you can see it here. Then we have how to convert TensorFlow model, how to convert PyTorch, Paddle. Many notebooks about asynchronous mode, demos for some super resolution, style transfers, and of course many notebooks, interactive notebooks with webcam. So for example, I showed you object detection with my webcam, but you can also try pose estimation, action recognition, style transfer, and many more.
Wow. Yeah, that's fantastic. That's an enormous amount of resources there. And does OpenVINO have, for example, a hosted service where if somebody wants to take their model and just pass it and have it be hosted for them, is that an option?
No, we have, I can show you this OpenVINO model, here, OpenVINO Model Zoo. It's here. So you can download any model from here, but unfortunately, it's not hosting service. Mm-hmm. We don't have something like that. We have also, maybe some of you are familiar with TensorFlow model serving. We have something similar. It's called OVMS, and it's OpenVINO Model Server, mm-hmm. and it works very similar to TensorFlow model serving. But unfortunately, you need to set up it yourself on your server.
Yeah, fair enough. That certainly makes sense. Yeah, that's fantastic. That's awesome. I think that we don't have any more questions. So if that's all, then thanks so much for coming on, and thanks everybody for listening.
Thank you, Ben. It was pleasure to be here.